We will be learning today about the very first chapter of chemistry, matter in our surrounding. Okay, sorry. These are the checklist of the chapters. The very first chapter of matter in our surrounding of ninth class. Matter, states of matter, change of states of matter, effect of change of temperature, pressure, evaporation, and plasma. Okay. So let's start with the very first topic, which is matter in our surrounding. Can any one of you tell me what is matter? What do you mean by matter?
Not anything that has a mass and occupies space is known as matter.
Yes, perfect. So please switch on our cameras. I want to see you all, guys. Shazan, yeah, Niti, hello. Yes. Anything?
Ma'am, my name is Amniti. My name's Advika. Just for today, I joined with my mom's account.
Oh, okay. Sorry. In a simple way, we can say that, right? Anything in this world that occupies a space and has mass in it, we can consider it as matter. Let me write it. Sorry. Anything that occupies a space. Correct, Shazan? Got it?
Yes, ma'am.
Occupies space and
Has mass.
Yes, mass in it, known as matter. So, do you know even the air around us is matter, although we cannot see it, right? Air is also a matter, agree?
Yes, it is a matter.
Yes, air is also a matter. All the things around us which exist in a variety of shapes, variety of sizes, and texture is a matter, correct? Sizes, shapes, texture, all are matter. Even air, although we cannot see it. Now, matter. There are three states of matter, which is anyone?
Solid, liquid, gas.
Yes, very good. Three states of matter. Very simple.
Ma'am, two states more are there. Plasma and bones, both Einstein condensate.
What, sorry?
Ma'am, two states more are there. Two more states are there.
Plasma and
Plasma and both Einstein condensate.
Oh, yeah. This is solid, liquid, and gas. Okay. Matter can be, just a minute. Matter can be changes from one state to another state, like a solid to a liquid or liquid to a solid. Correct? Matter can change from one state to another state, from one to another. Let me ask you one question. That, like, here my is solid, liquid, and gas. Hello, Sharia. Please switch on your camera. Yeah. So what is solid to liquid? Can anyone tell me?
Ma'am, solid to liquid is like ice to water.
Yeah, like ice to water. What's that process called?
Ma'am, that's called melting.
Yeah, so what I was saying, that from solid to liquid, it will be a fusion. If we heat a solid, it becomes a liquid.
Ma'am, fusion and melting is the same thing, right?
Yes, it's the same thing. It's the same thing. And from liquid to a gas, from liquid to a gas. What's that? It's very easy.
Ma'am, liquid to gas is evaporation.
Yes, very good. And what about you, Shazan and Sharia? No idea?
Yes, ma'am, what?
No, ma'am.
From
Ma'am,
liquid.
solid to liquid fusion and liquid to gas vaporization and liquid to solid solidification, solid to gas sublimation and gas to solid sublimation and liquid to gas vaporization and gas to liquid condensation.
Okay, nice. Yes, from gas to solid. Directly from a gas to a solid.
Sublimation.
No. Directly from a solid to a gas.
Gas to solid.
No, from solid to a gas is a sublimation.
Ma'am, gas to solid is not possible though, right?
From gas, it's a phase change from gaseous state to a solid state is deposition. But from liquid, from solid to a gas is sublimation. No? This one is sublimation. The transition, got it, no? Transition of a substance directly from solid to a gas without going through liquid. Liquid is not included, only directly from gas, it's sublimation. And what about this? Gas to solid?
Ma'am, gas.
I'm just told you deposition.
Deposition.
Yes. And from liquid to a gas, you all know. And what is condensation?
Ma'am, condensation is from
Condensation.
Gas to liquid.
Yeah. If we cool a gas, it becomes a liquid. That's
Liquid.
condensation. Very good. If we cool a gas, right, it becomes a liquid. And what about solidification? Last one.
Ma'am, liquid to solid.
Solidification is liquid to solid. Liquid to solid.
Very good. Very good, all of you. Solidification. It's easy, right?
Freezing, right?
Yeah.
It's basically freezing, right?
That's basically, sorry.
Solidification is also freezing, right?
We can also say it freezing. If we freeze liquid matter, it will become a solid. It's also called a freezing. Freezing as well as solidification, and from solid to liquid fusion as well as melting. Okay, any doubt?
Yes. No.
No, ma'am? If we freeze liquid, it will become a solid.
Ma'am, this applies to any liquid, right? Like if we freeze any liquid, it will become a solid.
Yes, obviously.
Including mercury?
It would be. Okay. Now, what we will learn next, we will learn the nature of matter. Do you know what is nature of matter? Nature of matter is classified into two categories. Nature of matter is classified into two categories. One is properties and another one is, any hint?
Sure.
Composition. The nature of matter can be determined by studying these two categories, the properties and the composition. Similarly, the physical properties of a matter can be observed or measured without changing its composition. right? Like physical properties basically means what? Can anyone tell me? This means basically what?
Ma'am, is that like the texture, color?
Yes, very good. Very good. Color, smell, density, melting point, boiling point. Yeah? Yes. Melting point. And last one is boiling point. Okay, Shazan and Sharia, all of you getting it right?
Yes, ma'am.
Okay, so let's have some fun. Means let's do some activity. Let's say this is my beaker. Okay. Here let me take 100 ml beaker and pour 50 ml of water in it. Let's say this is my full 100 ml beaker and here my this 50 ml is water. Yes. Now, if we will add 2 grams of sugar into the beaker and stir it with a spoon till all the sugar gets dissolved. Now let me add to this. Let's say this is my spoon and I am pouring the sugar in it. This is my sugar. Okay. So we will observe that the level of the water is the same. If we are stirring the, if we are putting the sugar in the water, then also my level is this only. Means this 50 ml only. Can anyone tell me why this level is not going up or any changes is not happening here? Why is this same? Why the mark is same?
Ma'am,
Why
is it
this
because the sugar dissolves inside the water?
Some diffusion between solid and liquid.
The volume has not increased, right?
Yes, ma'am. That's because the sugar dissolves inside the water.
Yeah. So we can say that dissolving sugar in water tells us that there are spaces between the particles of
Yes,
matter.
ma'am, and the sugar atoms make space between the water atoms.
Yes. Very good. So understood this activity now. This is just a simple one. You all know this. Now, let's talk about some of the points related to particles of matter. Particles of matter. Screen is visible. Voice is okay. Everything is okay, right?
Yeah, ma'am.
Okay, so particles of matter. What is particles of matter? The particles of matter are very, very small. It's tiny.
Atoms and molecules.
Huh?
Atoms and molecules.
Yes. And they have spaces between them. Particles of matter attract each other. They are constantly moving. Hai na? Yes, Shazan. They are very, very small.
Yes, ma'am.
Very, very small, like atoms, molecules.
Yes.
Ma'am, you said that atoms have spaces between them. Ma'am, but like in some states of matter, like solids, there are no spaces at all, right?
Yeah, they have spaces between them.
But it's too little.
It's very small, but they have.
Okay.
Okay. And particles of matter attract each other all. And they are constantly moving on.
And that is why compression of solid is possible, but it is very hard.
Yes, exactly. Particles of matter attract each other and they are constantly moving. And the fourth point is constantly moving. Yeah? Got it? Any confusion till now?
No, ma'am.
My matter, 3 shapes, solid, liquid, gas. All this, let me ask you, like, okay. So now tell me, like, what is sublimation?
Ma'am, can I tell?
Yeah, sure.
Ma'am,
Sublimation is the process due to which
It's a process.
sublimation is the process due to which a solid gets converted into a gas without being converted into a third state on heating.
Yes.
That's
Shazan,
what
agree? Agree with me?
Yeah.
Ma'am, my name is Advika.
What? Advika?
Advika.
Advika, okay, sorry. Okay, yeah, correct, Advika. Directly from a solid to a gas. And what is deposition?
And deposition is solid to gas.
No, gas to solid.
Yeah,
gas to
correct, Shazan, correct. Yeah. You also, Advika, from gas to a solid. Okay. Without passing through a liquid. Liquid is not. Now, solidification, the very easiest. What is solidification?
Liquid to solid.
Liquid to solid.
If you freeze liquid, it will become a solid. So every change of states now, you guys are done now, from solid to liquid, liquid to gas, back from gas to solid, and then from solid to gas again. Yes, correct. Good. Now the topic we will be learning is the states of matter. Okay. Now we will elaborate all the states of matter, the solid one, the liquid one, and the gas. Okay. So states of matter. Why camera is off? All of you, please switch on. Yeah.
Ma'am, I can't.
Okay, Shazan and Advika, your camera? Yes. Now it's like we are doing one-on-one.
Can you
Sorry.
see me?
No, I can't see you. Yeah, now it is. See, solid. It have a certain size, shape, and volume. The particles are closely, regularly, and tightly packed. Correct? What they have? It have certain size, shape, and volume.
Ma'am, so we can just, ma'am, can you directly just write that they have a fixed shape and volume?
Yeah, what?
Ma'am, can you just directly say that they have a fixed shape and volume?
Yes. Yeah. And the particles are closely, regularly, and tightly packed. Particles are what?
Closely and tightly packed.
Closely, regularly, and tightly packed. Correct. What else?
And they have a fixed mass.
They have a fixed mass. And please note this point.
The force of attraction between all others means
It's extremely large.
particles of solid is extremely yeah, that.
Ma'am, no, it's extremely large, right? Because it's a solid.
Yes, extremely large.
It's too much. And solid is rigid.
What else?
Ma'am,
Solid
the
cannot
solids
be
don't
compressed.
diffuse into each other.
Solids don't diffuse into each other like?
Like they don't mix. Like when two solids are kept next to each other, they don't mix together. Like unlike liquids and gases.
Sugar and salt.
Very good. And one more point, that the particles cannot move around much, but they can only vibrate in their fixed position. Okay, they cannot move here and there. They can only vibrate in their own fixed positions. Cannot move, but these can only what they can do?
Vibrate around their own
Vibrate
position.
around.
Yes, vibrate in their fixed position. Vibrate in their fixed position. Very good. Any more point? Any more point?
Ma'am, so can we write that particles can move only around their position, that is vibrate, because the force of attraction is extremely large?
Sorry, your voice.
Ma'am, can you hear me?
Yeah.
Ma'am, can you say that the particles can only move around their own position or vibrate because the force of attraction is very large?
Yes, they can only vibrate their own positions. They cannot move here and there. Okay, now let's talk about the liquid. Solid is done. Now liquid. So tell me, it have neither a definite shape nor a volume. Am I correct? No shape, no volume. Like CO2, no shape, no volume, no shape, no volume. The constituent particles are far apart and they can freely move. In solid, they cannot move, but in liquid, they can freely move. Getting it, Shazan?
Yes, ma'am.
Yes.
The force of attraction is less in.
Force of attraction is lesser in comparison to solids,
Yes.
but more than gas.
Force of attraction is less. That's why it can freely move. But in solid, it cannot. It can only vibrate.
Why, ma'am? The force of attraction is not less, right? It's
Huh.
moderate.
It's very less in liquid. It's very less in liquid, no? That's why it can freely
No
move.
force of attraction is
Ma'am,
there.
ma'am, shouldn't it be very less in gas?
There is no force of attraction in gas.
Wait. Yes. Shazan is correct. There is no force of attraction in gas.
I thought there was like very, very less force of attraction.
No, very less is here only in liquid. That's why they can freely move. Now, milk. What about milk? Milk is a liquid?
Yes, ma'am.
Yes, ma'am.
Yes.
Some they can diffuse.
Huh?
Some
Liquid
liquid can diffuse.
Yes.
No,
Milk-
ma'am.
And
Liquids
some
can't
liquids can
diffuse.
diffuse. Some
Ma'am,
liquids
some
can diffuse.
can't diffuse and some liquids
Like
cannot.
oil
diffuse.
and water.
Oil and
Milk
water.
and- Yeah.
Okay. Just say one.
Ma'am,
It's like-
ma'am, some liquids like oil and water can't diffuse together. Meanwhile, some liquids like milk and water can diffuse.
Milk has a size of volume, but milk doesn't have a definite shape. It only takes the shape of its container. If milk is there in this container, it can only take a shape of my container, but milk doesn't have a definite shape. Does not have a definite shape. Okay, Sharia, not a problem. Does not have a definite. Now let's talk about the gas. It have neither a definite shape nor a volume. But in liquid, no shape, no volume. Stay in solid, they have shape, volume, no shape, no volume. But in gas, neither a definite shape nor a definite volume.
And then there's no force of attraction.
Neither a definite shape nor a volume. Just write one here. Now, second one, the constituent particles are far apart and they move freely.
One can freely move.
Yes, very good. Far
And the
apart,
gases can diffuse.
far apart and freely move. Shazan, getting it?
Yes, ma'am. No force of attraction is there in gas.
No.
Gases.
Gas
And
can diffuse.
examples are oxygen and carbon
It
dioxide.
doesn't have a definite shape nor
Yes.
Ma'am,
no
gases can
definite
diffuse.
shape.
Ma'am, gases can very easily diffuse.
Yes, very, very good. Now, let me tell you this, that in physics, a state of matter is one of the distinct forms of the matter takes on, and each of the states is known as the phase. In physics, we call this phase. Solid, liquid, gas, these are the phases in physics. But here, these are what? What?
Ma'am, shades of-
What, Shazan?
No, what's the question?
See, in physics, we call this solid, liquid, and gas as a phase. Here also,
Ma'am,
phase.
states.
Yes, states of matter.
That's what I said. Say states of matter. Then it will.
Oh, sorry, I didn't hear you. Sorry, it's okay. Now, any doubt in solid, liquid, gas? Everything done?
Ma'am, I have a question, ma'am. When we say that gases can diffuse very easily, do we mean that like if we put two gases in the same room, they'll mix very easily, or that we need a chemical process?
No, they can mix easily.
Like if we spray perfume from one side of the room, then we go to the another side, it still smell it because it easily diffuses with its body.
No.
Ma'am, that's not diffusion, right, ma'am? That's the property that
Diffusion.
gases
It
can
diffuses
occupy a
into
space they are
air.
put in, because the force of attraction is very low and
That is diffusion, no? Yeah, Shazan, go ahead.
It diffuses into air, ma'am, and air is actually a matter. Because it occupies space and have mass. Like if you blow air in balloon, it occupies space. That is.
Yeah.
So, ma'am, when we say that, ma'am, so like, is that diffusion that we can smell the perfume from the other end of the room, or is it because that the force of attraction between the particles is very low? That's why the gases are occupying the space they're providing.
Come again. Your voice is little breaking.
Ma'am, is it better now? Can you hear me? Ma'am, so are we saying that we can smell the perfume from the other end of the room because of diffusion, or is it because the force of attraction between the particles is very, very low and the gas can occupy any space that's provided with?
Because of diffusion.
Ma'am, so what is it diffusing with?
What?
Ma'am, what is
Air
it?
particles.
The air particles are there, no? In the air, there are air particles, है ना? Doubt.
No, I understand.
Okay. Now the effects of change of temperature. Just a minute. Yeah. Let's go through these points. What is this? No, not this one. This one. The states of matter. This we know. See, here solid have definite shape, distinct boundaries, and fixed volumes. Correct? Solids have a tendency to maintain their shape. है ना? And what density? Density will be mass by volume. Yes. Sugar, sand, rocks, all are the examples of substance which exists in the solid state. Iron is a solid, aluminium is a solid, gold is a solid, all the metals are solid.
Ma'am, and all non-metals are liquids, I guess.
Yes. See, in liquid, what is liquid? Liquid do not have this definite shape. Liquids flow and change shape, so they are not rigid. We call it as fluid also. Liquid also called as no answer.
Ma'am.
Ma'am, can you repeat the question?
Yeah, liquid can be called as, one more name is there, na? See here. It's what's
Fluid.
it? Yes, fluid.
Fluid, okay.
Solid, liquid, gas can diffuse into liquid. The gaseous from the atmosphere diffuse and dissolved in water. This is correct. The animals can breathe underwater due to what? Due to the presence of dissolved oxygen in water. Like for example, fish. Fish can take oxygen, right, in the water, underwater, because of what? Because of oxygen in water, because water is having oxygen. Agree? No. So when people go inside the sea, they use the oxygen bags in their back, right? Because for them, how they will, breathe. But the fish is having that quality of breathing inside underwater. So water, milk, juice, oil, kerosene, petrol, benzene, all are the examples of liquid state. Yes? Yeah. Now, last one, the gaseous one. See, gas have a tendency to flow as liquids do. Therefore, they're also considered as fluid. Gas is also having a tendency to flow. Okay?
Gases can be easily compressed.
Yes, gases show the property of diffusing very fast into another gases due to a high speed of particles and large spaces between them. Gas is having a large spaces between them. That's why the property of diffusing is very fast in gas. Okay? And it's also high compressible. Now, like the particles move about randomly at high speed. Due to this random movement, gas exerts pressure on the walls of the container in which they are kept. See, here my solid, all the particles are bounded to each other. Hai? In liquid, they are little apart, but in gas, they are fully apart. Yeah. So in this figure, A, B, and C shown the magnified schematic pictures of the three states of matter. This one is solid, another one is liquid, and this one is gas.
Ma'am, like it shows like the particles are either close or far.
Yes. Very good. Now, change of states of matter. This we already know: fusion, boiling, sublimation, vaporization, and condensation. Any doubt in this? The changing of state, any doubt? No, sublimation, deposition, all are correct. Deposition, last one, you Advika. What is deposition?
Ma'am, for what is deposition?
What is deposition?
Oh, ma'am, deposition is the process due to which, ma'am, a gas gets converted into a solid.
Yes, very good. It's a phase change from a gaseous state to a solid state without passing the liquid state. Now, effect of change of temperature. Okay? Yeah. When a solid is heated, the kinetic energy of the particles increase. For example, a solid. Give me an example of solid.
Ma'am, any solid?
Any solid.
Table?
Table. Okay. Table. Here, what we have seen. Yeah.
Notebook.
Rock.
Notebook is also.
Yes, notebook is also a solid. So when we heat any solid, its kinetic energy will increase. For example, let's.
Ma'am, is it just for solids or is it like for all states of matter?
What?
Ma'am, is it just for solid or ma'am, it's for all states of matter, right?
No. Only when a solid is. For example, table. Let's take the example of table. When we heat a table, my kinetic energy will increase. See, when a solid is heated, the kinetic energy of its particle increases. Due to increase in kinetic energy, the particles starts vibrating. So I have told here that, where is that? Yeah, see, solid is what cannot move, only vibrate in its fixed position. Now, and here is also written that it will start vibrating in its in its own area. It won't move here and there. If we will heat this, like for example, table, will it move? No, no. It will only start vibrating in its own position. The energy supplied by heat overcomes the forces of attraction between the particles. What it now? If we are heating anything, then it's not moving. It's only vibrating in its own.
Yes.
Table will what? Vibrate in its own position. So from which school you are, Advika?
Ma'am, I'm from National Public School in Bangalore.
Okay, good. And Shazan?
Ma'am, I'm in not literacy school.
You are not in any school?
Ma'am,
Oh, what are you saying?
ma'am, I'm in not literacy school.
Oh, sorry. I thought you are not in it. Okay, good. In the way?
No, ma'am, Jamshedpur.
Okay, nice. Now the particles leave their position and starts moving. Particles leave their position and start moving more freely at a certain stage, melting point. Solid melts and it's converted into a liquid. Give me an example, like for example, ice. Hai. If we will melt the ice, it will convert into a liquid. It's very easy. You all know what will happen if we heat a solid. Hai na? Yeah. At a certain temperature, a point is reached when the particles have enough energy to break free from the sources of attraction of each other. See here, solid, liquid, gas. If we will heat, it will become a liquid. If we will heat again a liquid, it will become a gas. For example, if we will heat a water, obviously it will become a gas. Hai na? And if we will cool a gas, it will become a liquid. Yeah. And again, the back process, if we will cool a liquid, it will become a solid. If we will keep water in a freezer, it will become a solid ice. Correct?
Ma'am, can you just show like the diagram of the like liquid, solid, and gas?
Which diagram?
Ma'am,
that
I got it. Yes, ma'am.
This one? Yeah. Solid, liquid, gas. Very easy. See here what's happening. Let me change the color. Solid, liquid, it's heating, right? Heat. This also heat. This one is cool. This one again. Cool, right?
Yes.
Okay. Can I change now?
Okay.
But I will provide you the PDF of all this. No need to copy. Like
Ma'am, I remember it better when I wrote it down. So.
Oh, good. Here, the same thing is written, the fusion one, the vaporization, and the sublimation. Now, you all are very familiar with these words. No need to go through this again, or we need. Any doubt in any of the fusion, vaporization, sublimation, anything? Last question. What is condensation?
And the process due to which a gas becomes a liquid on cooling. The process due to which a gas becomes a liquid on cooling.
Yes, very good. At the same time, you all, very good. Now, scales of measuring temperature. There is a formula of measuring a temperature. 3 scales. Temperature on Kelvin. Temperature on Kelvin scale is equal to temperature on Celsius plus 273.16. So it will be like this. See, this TK is Kelvin. And what is TC? Celsius.
Ma'am, I understand this part.
Oh, you know this part?
No, ma'am, I didn't understand this part.
You didn't understand which part?
And the scale one, like, ma'am, what is like Kelvin? What is? Ma'am, I just know Celsius. I don't know what Kelvin is.
Yeah. I'm telling. Kelvin is a SI unit of temperature. Okay. So here TK is my Kelvin, TC, and this. So here it's written also. Kelvin is the SI unit of temperature. For example, 0 degrees Celsius is 237.16 Kelvin. Now this number you guys have to little memorize. That 273.16 is Kelvin, and these 3 formulas you guys have to memorize by heart.
Ma'am, you'll send the PDF now.
I will send.
So, ma'am, we'll actually we'll write it down from the PDF. And you explain us and give us some sums to do to convert this much Kelvin into this much Celsius.
Okay.
In my school, ma'am, the sir covered till this topic in 2 weeks.
In 2 weeks?
Yeah, 2 or 3 weeks.
I taught in only just 40 minutes.
Ma'am,
Who
for
taught
us,
better?
school hasn't even started yet. It's summer vacation here.
3 days it was,
3 days.
3 days chemistry in a week.
So you understood now? Shazan?
Yeah, now understood.
So your sir was better or I?
You are better.
Oh, I'm better. Okay, thank you.
We can't even hear him what he says. He says like very low.
Who, sir?
Yeah.
Every school this now.
Yes, ma'am. The teachers are good at explaining, but they take a lot of time because there's a lot of dumb children in class.
One chapter they'll take full 1 week. है ना?
And then there are some students who just waste the time, say that they
Yes,
get the
ma'am.
even if
Students
they
don't
understand.
understand anything.
Okay, now you guys understand everything. Now there's this. We will provide you the that assignment or in which there are all the different types of questions relating to how you can convert from a Kelvin to a Celsius, from Celsius to a Kelvin, because it's already 5:45. See, here is one example for you, Shazan. Convert the temperature of 200 degrees Celsius to a Kelvin. Come on, I will not.
What is the formula?
What was the formula here? You
Ma'am,
tell
the
me.
formula was, ma'am, I think Celsius plus 270, no, wait, 273.16.
Let me show once again. See, temperature on Kelvin scale. Kelvin is equal to Celsius plus 273.16.
I was correct then.
You was correct. This was the Celsius and this for Fahrenheit scale.
Question.
Okay.
Question,
Shazan?
now, question. Yes.
Now let me ask you the question here. It's written. Let me just. Oh, the formula is also written. Let it be.
200 Celsius on Kelvin scale.
What will be the answer? It's very simple.
473.16 degrees Celsius.
It's written here.
Oh, ma'am, I calculated.
Ma'am, because
it,
we just have to add 273.
Yeah, only we have to add the 273 plus this. Now convert the temperature. Convert the temperature of this to Celsius. What we will do? Everything is written.
Ma'am, we minus. I mean, subtract.
We will subtract. So what will be the exact value? Come on.
I'm 200.
273.
216
No, ma'am.
point.
Just calculate it.
Ma'am, I'm calculating 1 minute, ma'am.
Ma'am, it is to convert it into Celsius scale. Ma'am, it is 200 degrees.
Ma'am, I'm not sure, but is it like 176.84?
Let me just reveal the answer. Yes, 179.82. Very good. What happened, Shazan? Where doubt? Only you have to minus now from 450 to 273.16 because
It is 450. Ma'am, but in the question it is 473.16.
no, it's 450 Kelvin. See,
So which question? I'm seeing the above question. That's 473.
above is 200.
Yeah.
Ma'am, and ma'am, can you please repeat the formula like we just did? I forgot. I think I wrote it down.
Yes. This Kelvin is equal to T Celsius plus 273.16. है ना? And what about T Celsius?
Ma'am, what is T Celsius?
Temperature.
Oh, okay.
TK minus 273.16. Easy. Just you have to bring this K here and the C here.
Like it's about addition and subtraction now.
Yes, that's it. Got it?
Yes,
These
ma'am.
two examples were very easy. And the last one was Fahrenheit. What was that?
Fahrenheit.
Yeah, this one. 9 by 5 degrees Celsius plus 32.
Can you give me 1 second? I want to copy it down.
This page only, no?
Question.
Ma'am, this is for the conversion of Celsius to Fahrenheit, right?
Which one? Temperature on Fahrenheit scale.
Ah.
Yeah. So everything got now. Class was not boring. Or it was boring.
Ma'am, it was fun.
No, what?
Ma'am, it was fun.
It was fun. Okay, thank you.
Can we leave?
I will leave now. You can leave now.
Okay,
It's
fine.
already 5. Thank you so much.